Alright, I am going to go over problem number 35, chapter 15.3, in which we are utilizing the fundamental theorem of line integrals to calculate the work done by a force field on moving an object from the point 0, 0 to the point 5, 9. Over the force field, 9x squared times y squared I plus 6x to the third minus 1j. There should be a j there. So in order to utilize the theorem, you need a force field which is conservative, in which the derivative of the j component with respect to x and the derivative of the y component, the I component with respect to y are equal. And in this problem, both the dn over dx and the dm over dy values will equal 18x squared times y, making this vector field indeed conservative. Alright, so now we need to find the potential function, which is equal to the integral of the f sub x dx, which in this case is the integral of the I component of the force field, which is the integral of 9x squared times y squared dx. Integrating that, you get 3x to the third times y squared the constant in this term carrying over, plus some c1 of y. It'll also equal the integral of the f sub y value dy, which is equal to the j component, the integral of the j component of 6x to the third times y minus 1. Integrating that, you get 3x to the third, x to the third, a constant term carrying through, times y squared minus y plus some c2 of x value. Alright, solving for our two constants here, c1 of y equals any term that contains just a y, and in this case it is just negative y, plus the constant k. And then c2 of x equals any term that would just have x in it, and there are none, so we'll just assign it the constant k. Thus giving us our potential function of the common terms between the two integrals of 3x to the third times y squared minus y plus the constant k. So now that we have that, we can solve our line integral or calculate the work done by simply subtracting the function's value at point P from the function's value at point Q, which in this case is the f of 5, 9 minus the f of 0, 0. The k's will cancel, and so we just substitute our 2 points in to the function 3x to the third y squared minus y. And in doing so, the function of 0, 0 is 0. So we calculate the final work done of 30,666 units of work. So to recap the problem, if you're given a force field that is conservative, in which the dn over dx and dm over dy values are equal, you begin by finding the potential function, f. And when you find it, you will then simply subtract the function's value at x1 and y1 from the function's value at x2 and y2. And when you do that, you will find the work done by the force field on the path, on any path moving from point P to point Q.